We are starting with cosine rule. First of all, the condition for cosine rule. There are two conditions. For instance, condition number 1, if all the lengths of a triangle is given without any angle. Okay, for instance, they are saying that this is angle A, angle B, angle C. Opposite to angle A is a small a. Opposite to angle B is side B. Opposite to angle C is side C. Now they are saying that, for instance, this is given, and this is given. I'm not adding any value. I'm just saying, okay, for instance, if it is given. So, how will I derive my formula? How will I work with my formula? For instance, if they are asking for angle A, so how will you write the formula? The formula will be cos of angle A. Okay? I have to find A. So I will write first of all cos of A. Now, which is the side opposite to A? Angle A is small a. Write it in negative squaring. Okay? The other two sides which are not opposite to the unknown one will be written in positive. This one will be written in negative, and the other two which is not opposite to the unknown which I am trying to find, that will be written in is positive squaring, and the one which is opposite to A, it will be written in negative squaring upon 2 times the one which are having squaring in positive form, they will be written in product without squaring. They will be written in product without squaring, and this is your first formula drive. Now, for instance, they are asking for angle B. So what will I do? I will write cos of B. Okay? I have written cos of B. Side opposite to B is small b, that will be written in negative square. I have to find angle B. So side opposite to angle B will be written in negative squaring. Other two sides which is not opposite to B will be written in positive squaring. Once I have written it, upon divided by 2, from the numerator, the ones which are positive squaring, not the negative one, will be written in the product form without a square, and you will have your formula to find the value of B over here. If I am going for value of angle C, so cos of C, angle opposite to side opposite to angle C will be written with negative squaring. Okay, and the side which are not opposite to C will be written in positive squaring. Divided by 2. Okay? Divided by 2. Now the ones which are positive squaring in the numerator will be written in product form without squaring, and you have got your formula over here. This is the pattern. Even if I'm going to give you XYZ or PQR or WXY, you can use this pattern. The angle which is supposed to be found, side opposite to that will be written with negative squaring. The other two sides will be written with positive squaring in the numerator, and in the denominator you will first write 2. Then the ones which are in the positive squaring in the numerator will be written in the product form without squaring in the denominator, and you will have your formula to find unknown angle. Now, cosine rule, condition number 2. When any two sides and inclusive angle is given, you will apply sine rule. When any two sides and inclusive angle is given, then you will apply sine rule to find the remaining ones. For instance, if I'm having over here x, y, z, okay, and opposite to x is small x, opposite to y is small y, opposite to z is small z. Okay. Now they are saying any two sides are given. So I'm saying, okay, for instance, if this is given and this is given. So any two sides are given, and inclusive angle means what? Inclusive angle means the angle which is coming at the intersection of these two lines which are given. So where these two lines are meeting, we have got Z, and Z is given to us. So now what will you do? If Z is given to you along with these two sides, you can go for a small z over here. Okay, you can go for this z. How will you do it? First of all, you will write this is missing one. If I will be going only for the angle, the side which is opposite to inclusive angle. Okay, if I'm having angle z, I can only find side z over here. Nothing else I can find. So what will I do? This will be written unknown one, z square equals to the one which are known. First of all, you will write them in a squaring form. Okay. Then positive squaring form you have written. Then you will write it without squaring form in the product form with 2 minus squaring form of given two sides in positive one, then with negative, these two given sides are being multiplied by 2 without having any square. and then you will write in the multiple form cos of given angle. Okay. So z square will be squaring of first inclusive, squaring of first side plus squaring of second given side minus 2 times of first side multiplied by second side multiplied by cos of inclusive angle. This is how you will always get your formula. For instance, they are saying that y is given to you and z is given to you, and side y, side z is given, inclusive angle x is given. Okay. So what you can find over here now, you can only find the angle which is opposite to inclusive angle. You can only find this one. How? Squaring of opposite angle equals to squaring of given two sides with positive sign. Then these two will be written without a square multiplied by 2. Before that I will put minus sign and cos of inclusive angle. Right? So in order to find this one, this term which is this side which is opposite to the inclusive angle, I will square it, where that will be equals to the square of first side plus square of second side minus 2 times product of given two sides with cos of inclusive angle. You will have your formula over here. As angle y is given to me, so I can only find this side which is opposite to angle y, which is of inclusive angle of side z and side x. So what will I do? First of all, squaring of opposite side equals to squaring of these two sides which are given minus 2 times of these two into cos of given angle. So these are the two rules which you have in order to apply your cosine. First one, if all three sides are given, none of the angle is given, then you can apply cosine rule. Second one, if two sides and inclusive angle is given, then you can have your cosine rule applied over here.